Good morning. Welcome to our special class. We're going to look at what is called the discrete random variables. The discrete random variables. Now we can define the discrete random variable simply as an outcome that takes on a numerical value as a result of an experiment. Now, with the term discrete, we mean an outcome whose values are not fractional or portional numbers. So when we're dealing with random variables, there are two types that we're going to look at. They are what we call continuous random variables. These ones are usually measured on a scale. Continuous values may take on decimals. So we have discrete numbers and continuous numbers. Continuous numbers, like that of weight, we could have 1.2 kg, 1.9. So these ones have a continuous scale. Weight is an example of what we call a continuous random variable. Time also is one of them. Liters of water, those are continuous random variables. But when you're dealing with the discrete random variables, we're dealing with measures whose figures don't fall in between. For instance, 1, 2, 3, 4 counting numbers. We have 5 children. We can't have 5.2 children. And so I'll take you through what we call the discrete random variables. We'll do about 3 questions. One of them will come in the exam. So we're given this example where we're given a number of students who are absent from a statistic class. We have 1, 2, 3, 4, 5, 6, and the probabilities should always add up to 1 as given below. So we're being asked to calculate the mean. We're being asked to calculate the mean. So with this very question, these are 3 questions. I need you to try one of them. Let me be as basic as I can. So the values two, 3, 4, 5. Then you're given the probability 0.1, 0.5, 0.2, 0.2. Question number 1, does the total add up to 1? Then we need to multiply these two, x and the probability of x. So 2 times 0.1 is 0.2. 3 times 0.5 is 1.5. 4 times 0.2 is 2.0. 5 times 0.2 is 2.5. Is it? 1, it's actually 1.0. So when you total up this, it's called summation of xpx. This is what we call our mean. So just total up this column, 0.2 plus 1.5 plus 2.0 plus 1. What we get is 4.7. So the mean sometimes is written by the letter E and X, not summation of X, no. Or it is just put in as mu. How did we get it? 2 times 0.1. Also multiplied what? 3 times 0.5. Also multiplied what? 4 by 0.2. So multiplied 5 times what? 0.2. Then the final answer we'll put in is 4.7. So this is how we calculate our mean. So you can either use a table or calculation differently. You get your 3 marks. Are we together at this point? Then we go to squaring these figures here. Square the values of x. We have 4 here. We have 9. We have 16. We have 25. Simply bring your probabilities here. Probabilities we have following 0.1, 0.5, 0.2, another 0.2. By these two, we're going to have x squared and probability of x. 4 times 0.1, 4. 9 times 0.5, 4.5. 2 by 16 by 0.2, we get 3.2. 5 by 0.2, we get 5. So when we add all these, we ultimately get 13.1. So this is called the summation of x squared px. So we get 13.1. So to calculate the standard deviation, we simply subtract the value here minus the square value here. So our variance will therefore be summation of x squared px minus the mean squared. So 13.1 minus 4.7 squared. So let's go through again what we've done. We're given these two values here. So how do we get this column? 2 by 0.1, we got this. 3 by 0.5, we got 1.5. 4 times 0.2, we get 0.8. Yeah. Then when we multiply 0.8, 5 times 0.2, we get 1.0. When we add 0.2 plus 1.5 plus 0.8 plus 1. So when we add them, we get 3.5. That would be our mean, 3.5. So that's how we get the figures here. And how do we get the other columns? We squared here, we get 4, 9, 16, and 25. And just bring back the probability here. With 1.5 plus 2 and 0.2 there. So after doing that, we then multiply the two columns, then multiply the two columns to calculate our value of x squared px. So the x squared px is actually not the it's not the variance, it's actually the sum of x squared px. So when we added in this column, we found the total that is showing there, 13.1. So we're going to subtract 13.1, 3.5 squared. The value we're going to get is variance. So this is 13.1 minus 12.25. So we get 0.85. This is what we call our variance. Get our standard deviation to square root the variance, 0.85. So square root of 0.85 gives us 0.21. So this is how we get our value of the standard deviation. Okay, so I'll ask you now to try the following questions. Questions are coming from this. So you try these two questions. So quickly, I want you to find our standard deviation and also to calculate the value of the mean and the variance. Quickly, I'll ask you to go ahead. Get the value of the mean, standard deviation, variance. So what we have here are the values of x. We can square the values of x. Have 1, 4, 9, 16, 25, and 36. And we can find x px, x squared px. So let's find x px. 1 times 0.12, 0.12. 2 times 0.15, get 0.3. 3 times 0.18, get 0.54. 4 times 0.15, get 0.6. 5 times 0.26, get 1.3. 6 times 0.14, 0.84. Then when we go to the other part, so with the other part, we can add up here 1.3 plus 0.6 plus 0.54 plus 0.3 plus 0.12. We get 3.7. Is that what you got? Then when you go to the squares here, 1 by 0.12, you get 0.12. 4 times 0.15, get 0.6. 9 times 0.18, you get 1.62. 6 by 0.1, 16 by 0.15, get 2.4. 5 by 0.26, get 6.5. Finally, 36 by 0.14, get 5.04. Add up everything. So add up everything. We get 16.28. So our mean is 3.7. Then when we square 3.7 and subtract it from 16.28, our variance, our mean is what? 3.7. Variance would be 2.5859. Then our standard deviation is when we square root the variance, which is 1.6. So you can do this. So this is a 3.7. This is how we get it by multiplying. So the average students absent per day is 3.7. Then you can also calculate the variance and standard deviation using this formula or the formula I gave you. When you total them up, the mean you subtract from each individual element and square it and multiply by the probability. Although if this is longer, you're going to get 2.59, which we already found here. 2.59. And when you square root it, you get 1.61. That is how you find standard deviation. All right. Are we all clear? All right. So I also want you to try this one out. Find the mean, find the standard deviation, and you need to find the variance. So let's participate. I'll find the mean. Maria and Dingiswayo, you can lead us through, and Munda. What do we do?
Pardon?
How do we calculate the mean? The values of x squared here, what do we have?
9, 16, 25, 36.
X. And I'll define x squared bx. So here what are we multiplying? 3 by 0.2.
3 times 0.2.
75. Then 4 times 0.55. 2. Then 5 times what? 0.15.
0.15.
So
6
0.75.
times 0.05.
Then 6 by
0.05.
we get 0.3. Then when you add them up, we're going to get 4.
4.
And here we're going to now multiply 9 by 0.25. Get 2.25. 0.55. We get 8.8. 5 times 0.15. We get 3.75. 6.005 and 0.05, we get 1.8. And total them up, we get 16.6. And when you square this 4 squared, you get 16. So the 4 is our mean. 16.6 minus 6, we get 0.6. 0.6 our variance. And when you square root, we get our 0.77 as a standard deviation. So we get 7 marks for this. So our mean was 4.0. To calculate the variance and standard deviation, you create the table below. I don't like this table. Then you get our variance as 0.6, as we did here. And when you square root it, you get your standard deviation as 0.77. So please, you can't miss our 7 marks in there. Is that clear? So I will lastly ask that you try some of the questions that I will give you later on. So this is how we do the discrete random variables. This is how we do the discrete random variables. And we're going to look at binomial distribution. We're supposed to have an hour, 130 minutes. So binomial distribution has the following characteristics. Binomial distribution has the following characteristics. The name bi, it means 2. So number 1, we have 2 possible outcomes. Number 2, we have equal chance. 3, we have
Mr. Collins, just a minute. I want to know which column you use to get the variance and the standard deviation.
I'll send the video for that one.
Okay.
We have 2 possible outcomes with equal chance. Okay. And events occur independently. So binomial distribution follows a combination formula. We multiply compute it as follows. Okay, and x and p to the power x cubed n minus x. So we need to learn how to find the combinations. In the combinations, you need to learn how to draw the Pascal's triangle, which is drawn as follows. You have 3 ones here. Then you add 1 plus 1, we get a 2. You add 1 plus 2, you put a 3 there. 2 plus 1, you put a 3 there. Then you close here. Then here we're going to have what? 1 plus 3, we have a 4. Here, 3 plus 3, we have a 6. 3 plus 1, we have a 4. Then you close. Then you're going to have what? 5. Then here we're going to have what? 10. 6 plus 4, another 10. 4 plus 1, we have 5. Then you close with 1s. Then again here, 1 plus 5, 6. Here you get what? 15. Here what do we get? 20. Here what do we get? 15. 5 plus 1, 6. You close here. Then here we have 1 plus 6. You get a 7. 6, 21, 35, 35, 21, 7. You close. You go on and on, but maybe up to 7. How do we use this to calculate the combination? For instance, I want us to find the combination of 6, combination 4. By 6 after 1. So we count it 4 times. 1, 2, 3, 4. So 6 combination 4 is 15. Okay. Then we go to 7 combination 3. Who wants to try 7 combination 3? So where the 7 add 6 3 times. 1, 2, 3. So this is 35. So quickly, a number combination 0 is 1. So 7 combination 0, this is 1. So 0, 1, 2, 3, 4, 5, 6, 7. A number combination itself is 1. So 7 combination 0, 7 is 1. 7 combination 6 is 7. 6 combination 5 is 6. A number combination, the second last number is itself. So 5 combination 4 is 5. So what is 7 combination 3? 7 combination 4. We go under 7. 0, 1, 2, 3, 4. It's 35. So that's how we use our Pascal's triangle. But the calculator also has a way of finding the combination without calculating, as we have done. So I can also teach you how to use a calculator to compute the combinations. So let's go to our calculator and try out the following experiment. So the calculator looks something like this. So if I ask you to find 7 combination 3, you go under 7 combination 3 equals, what do you find? What is 7 combination 3?
35.
35 directly. How about 10 combination 3?
120.
Correct. So there's also a factorial here. A factorial, for instance, 4 factorial is simply multiplying 4 backwards. 4 times 3 times 2 times 1. So this one gives us 16. 24, sorry. You can simply calculate on the calculator here, 4, then shift, then this pattern just below shift. Those that are using a sharp, under 5 or 4 somewhere, there's an n factorial. So 4, shift, I think it's what, 5 or 4. So what is 4 factorial on the calculator? And give me 5 factorial on the calculator, and give me 0 factorial on the calculator.
Four factorial is 24.
Okay. But
5 factorial 120.
0 factorial.
0 factorial 1.
Good. So 0 factorial
1.
is 1, not 0, correct. Now with this knowledge here, I can now safely take you through a binomial distribution. So binomial has only 4 formulas. Number 1, the general formula of the combination px q n minus x. The second one is that your mean is simply np. Second one is that your variance is simply npq. The deviation is simply square root of npq. That's this 4 formula. So you need to understand that for a binomial, you'll be given 2 things. So I'll give you an example. Let's say, suppose your n is 6, your probability is 20%. Find A, the probability of x is equal to 0, 1, 2, and 3. And B, your probability of at most what? 2. Maybe probability at least 2. Then finally they'll ask you to find the probability. Probably they just ask you to find the mean, the variance, the standard deviation. So let's find these quickly. So the probability of 0, set with the probability of 0. To find the probability of 0, we use the formula n combination x. So n is 6. So here's the formula n times the probability of x to the power x times the probability of q to the power n minus x. So if our p is 20%, our q should be the difference from 100, which is 80%. So you shouldn't have any problems in identifying your q. So x is equal to 0, our n is 6, our x have given us 0. And the p is 0.2, which is a 20%, and our q is 0.8, which is 80%. According to the formula, this one comes here. Then the difference, 6 minus 0 is 6, comes there. The 2 must add up to what is on top. How about if we had x is equal to 1? This is 6 combination 1. Here we have 0.2, 0.8. Where does the 1 go? It comes here. Then 6 minus 1, we get a 5. So 5 plus 1 is asking 6, yes. Then we'll compute the answer later. Let's try to find x is equal to 2. Simply pattern. 6 combination 2. So here 0.2 and 0.8. Where does the 2 go? On top of the 2. What comes on the 8? 6 minus 2, 4. How about x is equal to 3? We have 6 combination 3. and 0.2 here, and 0.8. What comes on top of the 2? The 3. 6 minus 3, another 3. The 2 add up to yes. Now let's compute. What is 6 combination 0? We said any number combination 0 is what? 1. What is 0.2 to the power 0? It's also 1. What is 0.8 to the power 6? You compute that. So only 2.8. Yes, we get 0.262. So and answer 0.262. Then 6 combination 1, you can go on your calculator, but I told you using the Pascal's triangle. And number combination 1 is that number itself. So 6 combination 1 is 6. 6 combination 2, 15. 6 combination 3 is 20. 6 combination 4, 15. 6 combination 5 is 6. 6 combination 6 is 1. So 100 combination 100 is 1. 100 combination 0 is 1. In number combination 0 and itself is 1. In number combination 1 and the second last number is itself. So 100 combination 1 is 100. 100 combination 99 is 100. Okay, so don't abuse the calculator on other parts. So 6 combination 2, when you do 6 combination 2, it's 15. Now we're here, 6 combination 1 is 6. 0.2 to the power 1, 0.2. 0.8 to the power 5 is 0.3, 2, 7, 6, 8. 6 times 0.2. So don't round off, you round off at the last stage. So you're going to have 0.393. And go 6 combination 2 is 15. 0.2 squared is 0.04. 0.8 to the power 4 is 0.4096. Multiply this by 15, multiply this by 0.04, you automatically get 0.246. Go 6 combination 3, will give you 20. And 0.2 to the power 3 is 0.008. 0.8 to the power 3 is 0.512. So multiply all these together, you get your final answer 0.08192. This is how you find the probabilities of each of these ones here. Of course, examiner will sometimes say find the probability that none will do this. None means 0. Exactly 1, exactly 2, or exactly 3. But sometimes examiner will say at most 2. English is a prerequisite for this course. At most 2 means what? 2 and below. So 2, 1, and 0. At least 2 means 2 and above. At most 2 means 2 and below. So we're starting from the probability of 2 going downward. So 2, 1, and 0. What's the probability of 0? We already have it. It is 0.262. Probability of 1, we have it. 0.393. And finally, what's the probability of what? 3. No, probability of 2, we have it. 0.246. So when you add 0.262, 393, 0.246, it's 0.901. Then here we go to at least 2. At least 2 means what? Probability is greater or equal to 2. So this means we're starting from 2, 3, 4, 5, up to number 6, since that's our n. Now this is very tedious. Probability of 2 plus a probability of 3 plus a probability of 4 plus a probability of 5 plus a probability of 6. Take the whole day. The shortcut is what is missing here. What is before this? It is 0 and 1. So to find, we know that from 0 up to 6, the total should be 1. So the shortcut is simply probability of x is at least 2. It's simply 1 minus what is not listed there. Probability of 0 and probability of 1. So when you subtract them from 1, you get the remainder. Because we know that from 1 up to the rest, it is 1. So just find the simple ones, 1 and 0. We'll subtract them from 1, so what remains is the probability of the remainder. So the probability of 0 is 0.262. Probability of 1 is 0.393. So 1 minus 0.262 minus 0.393. So we're going to have 3, 4, 5. This is the probability of at least what? 2. Suppose they said at least 3. We're talking about 3, 4, 5, 6. But which ones are not listed? 0, 1, and 2. So we would have subtracted probability of 0, 1, and 2 from 1. So you need to know when to subtract. Just on that one, suppose your n was 10. And you're told at most 8. Most 8 means 8 and below. So it means 8. It means 1, 2, 3, 4, 5, 6, 7, 8. Now this is a lot as well. You need to know when to subtract. You subtract when there are too many things to do. But we have only 9 and 10 remaining. So the best way is simply to find the probability of 1 and subtract not probability of 1. The figure 1, subtract the probability of what? And the probability of 10. You add these two and you subtract them from 1. That is when you're asked to find at most what? That is when you're asked to find at most 8. So if there are 10 and you're told to find at least 8. At least 8 means what? 8, 9, 10. These ones are easy. Just do them directly. Probability of 8, add the probability of 9, add the probability of 10, and get the final answer. But if there are 10 and you're asked at least 2, it means you need to start from 2, 3, 4 up to 10. That's a lot of work. The easiest one is to find the probability of 0 and 1, because 2 up to 10, there are too many. All right. So lastly, we've been asked to find the mean, the variance, and the standard deviation. The mean is simply n times p. So our mean here is what? Our n is 6, our p is 0.2. When we multiply this, we get 1.2. Our variance is npq. So 6 times 0.2 times 0.8. So you get your final answer. Then you square root it. 6.2 times 0.8 is 0.96. And the square root of 0.96, you get 0.98. Now, let's look at how an exam question comes. Okay, so I want to take you through last year's paper on this subject matter. Binomial usually comes. So you need to look at how to binomial. Okay, so an example of a question that required binomial. Of course, eventually it will be important to know when to use binomial. That will be the question. How do I know this is binomial? That is a lesson for another day. Given this question here, say, suppose a 10 multiple choice question where there are 4 choices being administered. What is the probability that a person who randomly answers gets fewer than 3 questions correct? So to start with, n is 10. The probability of getting a correct answer out of 4, one of them should be correct. So 1 out of 4 should be correct. So meaning this is 0.25. So our P is 0.25. Meaning this is probability of a success. The failure is 1 minus P. So how many answers are wrong? There are 3. So 1 minus 0.25 is 0.75. Meaning this is our Q. Now, what is the probability that you answer correctly fewer than 3? So being asked to calculate the probability of X is less than 3. So what are they asking us to find? Probability of what? 0 plus probability of what? 1 probability of what? 2. We include the 3? No. It says fewer than 3. So how do we find the probability of 0? We already explained how to calculate the probability of 0. 0 is 10 combination 0. And the P here is what? 0.25. And the Q here is what? 0.75. So the 0 comes here and the 10 comes there. And we've got the probability of what? Of 1. 10 combination 1. Do the same thing we had. 0.25 here and 0.75 here. 1 comes here and the 9 comes there. And finally, probability of 2. Here I have 0.25 there, 0.75 there. The 2 comes here. What comes here? The 8. Add all these answers and collectively sum them up. That is fewer than 3. But if they said 3 or fewer, would have included the 3. And finally, assuming that each student in class guesses randomly on each question and the number of the correct answers per student is tallied, calculate the mean, the variance, and the standard deviation. So we know the mean is what? NP. The mean is N times the probability. So what is our N? 10. The probability was 0.25. So here we get 2.5. How do we get the variance? Our variance was what? NPQ. So here our N is 10, our P is 0.25, and our Q is 0.75. All right. So now define the standard deviation, you simply square root it. So I need you to do this question. I'll send you the questions on the groups. So we end here. Have a good day. My next class is managerial economics. So I will have to end here. Thank you so much. I'll be using the same link for the other group. So I'll ask those that are not taking managerial economics to exit